So just a preface to this activity, let's go backwards a little bit from where we were last time to where we were last time. We had done the models for subtraction. That's what I want us to look at. So one of the models for subtraction was take away. We talked about the idea of I actually have something and I'm going to remove something from something I already have. We talked about missing add-ins, the idea that I need something and I don't have all of what I need or whatever. We talked about comparison, where we're not taking anything away, we're not missing anything, we're just comparing two people's objects or something like that. And the last one we talked about was this number line measurement idea, the idea of measuring a distance perhaps or a length of something and then taking part of it off, but from a measurement perspective instead of from an actual counting perspective. So what I want you to do in groups is the next 4 slides, 2 slides, I can't even remember, they're 2 slides. You're going to create a word problem for each of those 4 models, you and your partner. Okay, so this is kind of like one of those practice for the test things, because I've asked you on tests before, so like create an example, right? Do you remember that? In particular, I'm thinking like the test one where I had to create a guess and check model or something, remember that? This is the same idea here. I want you to create an idea or create a word problem for each of these different models, okay? So you're going to create 4 different, formulas, 4 different word problems. You don't have to solve them. I don't need any pictures. You're just creating the problem, all right? It needs to be applicable to a young child. So please don't talk about ACT scores. You don't know what that is, okay? But something that would make sense to a kid, all right? So you guys are set to go. Okay, so here's what we're going to do. Everybody has some examples written down of these different types. You do not have to get up at the board, but you do have to say your example loud enough so the computer can pick you up, okay? So you only have to give one example. I've got 7 groups in here today, and there are 4 different problems. So I'm going to have 2 examples per problem, and then if somebody wants to go above and beyond for me and give an example on the last one, even though you were talked, then I would be very excited. All right, first one, takeaway model. Who wants to volunteer their example of their takeaway model? 2 volunteers. And I will volunteer you if you do not volunteer yourself. Thank you. Would you give us what you got?
Okay. Jimmy has 5 markers. Sarah borrows 2 of them. How many does Jimmy have now?
Perfect. And did that kill you? No, it was really No, she's still in one piece. Everything is still okay in her world. Somebody else, an example of their takeaway model.
Abby has 5 marshmallows. Carrington steals 3 of them. How many does Abby have now?
Excellent. Good example. All right, how about missing add-ins? That.
Piglet needs to collect 7 butterflies. He and Daffodil found 5 butterflies. How many butterflies does Piglet need?
Perfect. What else? One more group on missing add-ins. All right,
Cindy needs 12 badges to become the head Girl Scout. She has 6 badges already. How many more does she need to become the head Girl Scout?
wonderful. All right, comparison. Who wants to give me an example of their comparison model?
Carrington and Abby play dolls. Carrington has 4 doll dresses and Abby has 2. How many more dresses does Carrington have than Abby?
Very nice. So your group is now given 2 examples, right? So see, the 2 example group is already done, which means everybody else still hasn't talked. I need one more example of comparison model.
John has 6 dogs and Jenny has 3 dogs. How many more dogs does John have than Jenny?
Too many, right? Number line model. Maybe you have one for us?
Okay, we need guys 27 miles to school. She is on her way and gets stopped by traffic 5 miles to school. How far from school?
Excellent. Very nice. Lydia?
The school is 5 blocks from Anakin's house. He walks 2 blocks from his house to the school. How many more blocks does he have to walk to get to school?
Perfect. So a couple of things that I noticed is that everybody did a really good job of giving whole numbers. That's good, because we're supposed to be working in whole numbers. All of your examples would work with fractions and decimals and everything. It's fine for the most part too. Maybe not half the butterfly, but yeah. So it's perfectly good that you have used the example. Please use it. No, it's perfect. You did just fine. I was just recounting what I had said. So make sure that when you're working in this section that you do remember we're talking whole numbers, because it would have been really easy to say something, especially with that last example, right? That they drove 5.5 miles or something, and we're not dealing with that in this chapter, okay? And then also remembering that these are subtraction models. So in particular, that you're not trying to do something where you have the same kind of idea, but you're for some reason wanting to add them together, so that's good. All right, let's do one more slide on this, we'll be done with this lesson. We're going to talk about, and we've talked about this a little bit last time already, which of these properties might or might not hold, or would not hold for subtraction. So we mentioned a little bit of this last time. Yes?
What is whole, what do you mean by whole?
Whole numbers. So can somebody tell Carrington what we mean by whole numbers?
Not whole numbers, but whole. Like last week's.
Oh, right here, this word hold? Satisfied, they don't work. Yeah, it means they don't work. So they don't hold, they're actually not true for whole numbers with subtraction. All right, so closure property. Is that property work with subtraction? Warren says no.
Wait, I think I am wrong. I think I was confusing myself.
It's okay. Do you remember what the closure property said? Nope, closure's not part of this.
Would we know? Because if we do 3 minus 4, then it'd be negative, right?
Right. The closure property does not hold. Okay, so it's no, it does not hold. And what were the numbers you said, Lauren?
3 minus 4.
If you did, for example, 3 minus 4, they're both whole numbers, 3 and 4, and you subtract them, you get -1, and -1 is not an element of the whole numbers, right? Yeah, so no closure property for subtraction. What was the commutative property? Where you flip the order, right? Okay, so if you flip the order, will that hold?
No.
No. Can you give me an example?
3 minus 2, 2 plus 3.
So 3 minus 2 is 1, 2 minus 3 is -1, and these are not equal, right? So if I switch the order, if I commute things, subtraction, not going to work. How about the associative properties? No. We need to do an example of it, though, to show that it really doesn't work. So what can I do? Somebody give me some numbers. 6 minus 4 minus 2. And we'll use the same numbers. Oops, sorry about that. Same numbers. But we're going to do the 6 in front and then minus, and then the 4 minus 2 here, right? So our question is whether or not when I regroup it this way, it works. Okay, or not. All right, so 6 minus 4 is 2. So this is 2 minus 2, which is 0. On the bottom one, 4 minus 2, which is in the parentheses, is 2. So this becomes 6 minus 2, which is 4. And again, these are not equal. So no associative property for subtraction of whole numbers. Last one, identity property. Okay, so why would the identity property hold?
Subtraction from 0 is the 4 minus 0, that's still 4.
I agree. 4 minus 0 is 4.
But you can't do 0
But-
minus 4.
That's right. What happens if I try to do 0 minus 4? It's -4, and the identity property has to work with the identity element has to work whether it goes in the first or at the second spot. So none of them hold for subtraction. This is a no again as well, and the issue is that these are not both 4. One of them is 4, but the other one's not, and I should be able to subtract it in either order of them and get the same number. Okay, we all good?